Hello there. In this video, we're going to finish looking at the topic of functions. This section is about using a graph that's already been drawn, represented, but we're using it this time to help us find the solutions to that function's equation. In particular, we're looking at how to solve, and here we have a function where we put inputs into that function and the answer is 0. In other words, when the y, the output, is 0. So we're looking to be able to read off from a graph to find the points where that function has a y coordinate of 0, which is actually much more simpler when you have a look at it. So let's go ahead. We know that graphs can be used to help solve equations. Like with most things in mathematics, there are more than one ways to do something. We can use algebra or we can use a graph. We might be asked to find the value or the values of x, so to work out what the input is, because we remember that x refers to inputs and y refers to outputs. Now, if we're asked to find x to figure out what the input is, then we will always be given the output. We will be given y. And remember that we can use the symbol notation f of x, so all of this, which still means y. So it could either be f of x equals 0 or when y equals 0. They both mean the same thing. It means we know what y is 0, so find out what x is. Work out what the input is. And we remember that not only is x an input and y an output, but the x and y numbers are the coordinates, so that when we draw our graph, every bit of that function, be it a line if it's linear, or a parabola if it's quadratic, they are all points. And we want to locate the point on that function when the y coordinate is 0. Now, on a graph, that will be where it crosses the x-axis. And we will simply read off then the value for x when it crosses the x-axis. Now, it makes it a lot easier to understand when we can see a function. So we have an example here. So this is the graph of the function and it's called g. And the rule of this function is minus x squared, take away 2x plus 8. What type of function is this? Well, if you said quadratic, you would be correct. And we can see that it's quadratic because there is an x squared term. And from just the equation, we would know that it is a negative quadratic function because of the minus attached to the x squared term. And as you can see, it is negative. It's a frown, an upside down smile, a negative function. And we can also read off that the constant, the number that's not attached to a letter, is the number 8. And that means it crosses the y-axis at 8. And as you can see, so it does. There it is at this point here. There's the y-axis, and then where the number 8 is, that's where it's crossing it. Now, what we're looking at is we're going to work out how to solve this quadratic function, which is a quadratic equation. And that simply means knowing when the output is 0, so the function has the answer 0. Now, we have solved quadratic and linear equations before without a graph. We've solved them using algebra. So hopefully some of this might be a little familiar, but it's much easier to do when you have a graph. So in an exam, you might be asked to either find the solutions or solve the quadratic equation, or simply to solve f of x equals 0. It all means the same thing. It means that we must look at the function and we must find the place or places where it crosses the x-axis. Because if you look at this x-axis, that's the axis, the black, the line that goes across here with all our numbers on. Every single one of them has the y-coordinate of 0. And we're trying to find when y does equal 0. So we're looking for where it crosses this x-axis. And now you can understand why it sometimes tells us to find the values of x, more than one. This quadratic function crosses the x-axis at two places. It crosses it here at the number -4 on the x-axis, and it crosses it here at the number 2 on the x-axis. So quite simply, there are two solutions to this quadratic equation. It is when x is -4 or when x is 2. So the graph of the function crosses the x-axis at those two locations. So therefore, the solution of the function equals -4 or x is 2. So your answer would simply be x equals -4 and x equals 2. Like with the previous video, we were finding out what y was when we're given x. We were looking for the outputs when we knew what the inputs were. Well, today's lesson is the other way round. We're looking to find out what the x is when we know what the y is. And the y, when we're asked to solve, is always 0. So we're always going to look to see where our functions cross this x-axis. Now, if a function is linear, it will only cross the x-axis at one place. So there will only be one answer. For example, if a line crossed the axis here, it would have an answer. The solution to that linear equation would be x equals -2. Now, it's something really important that, again, as we know how important keywords are in mathematics, but the solutions to an equation are quite often in exams referred to as the roots of the equation or the roots of the function. Now, if you imagine this parabola, if you think about the x-axis as being the ground and then above that is the sky, and then you can think of this as a plant or a tree, the parabola, then suddenly it changes from tree to underneath the ground is its roots. So where it changes from a tree to its roots is the x-axis, where it crosses these 2 points here. So that can be quite helpful. Imagining it to be a tree and where it suddenly has its roots can help you to understand, to remember that it means find the solutions to the equation. So the values for x when the answer is 0. So if we were to check or verify our answer, quite often we might then be asked, verify your solution using algebra. Then we could simply rewrite the equation. So that's the right-hand side of the function, -x² minus 2x plus 8, and then change the x to each of our values that we think are the solutions. So first of all, we would change x to -4, and we would then calculate the left-hand side, and you would find that it does indeed equal 0. We would then do the same thing for the second root, the second solution, change x to 2, and again you'll find the answer is 0. Let's test this out on the number 2. -2 squared minus 2x plus 8. Well, don't forget that with BIMDAS, we always do the index first. So our x is a 2, and we must square it. That means times it by itself. So 2 squared becomes 4. And then we have minus lots of that. So we've got minus 4. Then we have minus 2, lots of 2, because our x is the number 2. And minus 2 times a positive 2, a minus and a plus makes a minus, and 2 2s are 4, so we get minus 4 again. So minus 4 makes minus 8, and then we have to add 8, and the answer is 0. So as you can see, that's what we have done. We have found the values for x, so that when they are put into our function, the answer is 0. So using algebra, it's swapping them in, substituting these values in. But when we are using a graph, it's very easy. We look and see where it's crossing the x-axis.
I'd like us to look at a worked example that's in your textbook. Sometimes these questions have a lot of writing and they can look quite daunting and intimidating at first. Please just take them step by step. Make sure that you read everything thoroughly though, because you could miss something that's really important, and don't be afraid to underline anything that you think is really useful or that you would need to remember later on. So it asks us to draw the graph of the function, and here we see it's called f, and you can see that the rule has an x squared term, so it's a quadratic function. It's going to be a parabola, a curve, and the x squared term is positive, it's not negative, so it's going to be a smile, and also the number that's not attached to x is minus 5, so it's going to cross the y-axis at the number minus 5. So if we were to do a quick sketch, you would know that it would look something like this, and that point there would be minus 5. Remember, a quick sketch is not accurate, it's just to give you an idea of what it should look like. Now it tells us that the domain that you're to use, so the inputs for this function, range from minus 2 to 6. So we would start off then using an input-output table, and we know that for a quadratic function we have to find every single input and output, starting with the smallest number going all the way up to the largest. So we would have to use the input minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. And we know to not worry about this part here. This is simply telling us that this function is all the real numbers, that there's nothing that we haven't studied yet, nothing untoward about this function. So let's just have a look at that first of all, drawing the graph, that very first sentence. So we know that we start off by drawing our input-output table, and the input table, output table has 3 columns, but what you see here is an additional column, and that is the ordered pairs or couples. If you're somebody that sometimes forgets to write the couples or ordered pairs underneath, then you can put them to the side. So if you look, the first number is the input and the second number is the output, which we know becomes a point that we plot to draw the function. So here is the function, and to get those points, as we said, you started off with the left number in the domain, so the minus 2, the number to the left of the x, and then you've written down every single value from that number all the way up to and including the number that's to the right of the x, so that's the number 6. So there's all of those inputs. Now every little bit of this is all worth marks, so this is definitely not a question that you would simply not attempt. You always keep going. You know that there are lots of marks to pick up. If you get something wrong, it doesn't matter. You keep going because you'll get more marks later on, and you can only be penalised once. You can't be marked down for getting something else wrong based on a previous inaccurate result. Now, where people have started to make mistakes when I've been looking at your previous homework submissions is simply performing BIMDAS. So remember that this middle column here, you need to have plenty of space so that you've got lots of workings. We replace the x each time. So this is the right hand side of our function. That's the name of the function. We write it out exactly the same again, but instead of the x, we put a bracket and we place the input that we're actually looking at for this particular instance. So this one, it's -2. So each time there's an x, we change it to -2. So with BIMDAS, you must always do the x squared, the input squared first. So -2 times itself. And remember that 2 minuses make a plus. So that becomes +4. And then we've got this number multiplied by this number. So this minus is actually attached to the 4. It belongs to the 4. It's -4 times -2. And -4 times -2, 2 minuses make a plus, and 4 times 2 is 8. So that's a +8. We've got +4, +8. So 4 plus 8 makes 12, and then we must take 5 away from it to get 7. So that's exactly the same procedure that will be done for each of these inputs to find its output, and then together that input and output will form one of the couples, which we will then plot on our diagram. Now, the other thing I noticed from looking at your homework was that people are still not getting these smooth curves. You really can't, you never use a ruler and you can't go jaggedy between each point. You really do need to kind of find the path. If you look ahead of, not just to the next point, but to the one after that, and you're trying to then go through it. And then once you've passed that next one, you're doing the same thing, looking at the next one ahead and going through. So these are each of these points. For example, -2, 7. So -2 on the x-axis and +7 on the y. It's that point there. So once all of the couples have been plotted, you're drawing this curve. You're writing the name of the function. They've just put f of x here. So you can label the function, make sure you've labeled your axes. Okay, so what does it ask us to do then? Let's continue to read the question. It says that this function represents the temperature on a certain day. So this is how you can use a function in the real world. And it tells us that 0 on the x-axis is midday. Okay, so what it means is that the further to the right is time. And this is midday, and we know that midday is noon or 12 p.m. So before that, one before it would be 11 a.m., 10 a.m. One after it would be 1 p.m., 2 p.m., 3 p.m. So these numbers are a bit easier to figure out the time, because the positive ones, because they're the same value as the number on this axis. The ones to the left are a little trickier. It's just remembering that if this is noon, midday, 12 p.m., the hour before, the one exactly before it is 11 a.m. and this is 10 a.m. And you may even want to actually write that in to help you. So 11 a.m. and 10 a.m. just to give you a little bit of an easier way of understanding what we've got here. So our function is the temperature for those different times of the day. So for example, at 2 p.m., so that's find 2 on our time axis, our x-axis. Now, where is the function level with the number 2 on that axis? It's down here. So we would read off then from that over to the y-axis. We know x is 2, the time, and the y is our temperature, and it's the number -9. So -9 degrees Celsius. So it tells us that midday is 0, and 1, 2, and 3 is 1 p.m., 2 p.m., 3 p.m., etc. And that the y-axis is the temperature in Celsius degrees. So then it's asking us some questions. First of all, estimate. Now we know we're estimating with quadratics because, as we said before, these are drawn freehand, so yours might be slightly out compared to the person beside us. So we know that they're just simply a guide. So we're trying to find the temperature when it is 4:30. So first of all, it's ensuring that you understand time and being able to convert from 24-hour to 12. And we know that the first set of 12, and then we continue to add on. So you can simply take 12 away from this number. 16 take away 12 makes 4. So it's 4:30 in the afternoon, the second time around on the clock. So that means on our axes, if it's 4:30, that's halfway between 4 and 5. So we want to find the function that's level with this. So again, remember, we always show our workings, so a dashed line until you get to the function that's level with this 4.5. You can see it's down here. So a dashed line down until you reach it. And now we want to find out the temperature. So we find out what is that in relation to its y coordinate. So this point is 4.5 on the x-axis, and you can see it's minus 2.8. So about minus 2.8 degrees Celsius. So you can simply then write your answer as minus 2.8, and then don't forget your units, degrees Celsius. Now part B tells us what is the lowest temperature and the time it was recorded. So if we're thinking about this as the temperature, look, the y-axis, the highest you go is the highest number. So the lowest temperature will be the furthest point down here. Well, then it means it's asking us for the very bottom, the very minimum point. It's asking us here to work out not only the temperature, so that's -9, but it's also asking us what time was that. And if we look up, it's at 2 on the x-axis, and that's 2 p.m. So our answer then for B is -9 degrees Celsius at 2 p.m. or 1400 hours. And then last of all, it says, estimate the times at which the temperature was -5. So we've been told that y, because we know y is the temperature, is -5. So we need to look at our y-axis, find -5, there it is. Well, that's handy, the function's already on it. So that's at the time level with the x equals 0. And we know that that represents midday. So at 12 noon, it's -5 degrees Celsius, but our function has another point level with -5 on the y-axis, and that's over here. So again, draw your dashed line out and then up to work out what time, what value on the x-axis that is. And you'll see it's level with the number 4. So at both midday, when x is 0, and 4 p.m. when x is 4, the temperature is -5. And just be careful to read the question carefully. It asks for the times for this one, but sometimes it might say give the points. If it asks you for the point, you must say the x and the y coordinate. So this is how functions can be used in the real world, and you'll have some time to practice some of those, your homework, and we will look briefly at them again then next year. Thanks for listening. One last thing before you go. What do you call a crushed angle? Why, it's a rectangle. Rectangle? See you in the next video.